So this is technological innovation and new media, and in this class we'll discuss about networking concepts. This part, a small part, we are actually dealing with networking concepts. So we'll discuss about first in first out, FIFO, priority queue. Then we discuss about FQ, which is fair queue, and then WFQ, which is weighted fair queue. So of course, this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for everything. Whenever you are doing any activity, maybe you will feel uh, very much confused. Even this semester, I am a little bit confused, literally confused with each and every activity. Every time before going to bed and after getting from the bed, we thank God, we pray to God. God, please help me bypass this situation. So as for me, I thank God for giving me this golden opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. So in this session, we'll have a short introduction towards first in, first out policy. Then we come out with the first come, first served scheduling policy. Then we discuss about a C++ program to demonstrate the working of FIFO using queue interface. We'll try to analyze the priority queue PQ and how the priority is being assigned to the elements in the priority queue, the descending order priority queue, how you can implement this PQ or priority queue, and a C++ program to implement the priority queue using arrays. Okay. Then finally, we end this class with a WFQ, which is nothing but weighted fair queuing. So I have independent work for you. You have to complete them. I will definitely, inshallah, by God's grace, definitely today I will post them. Please complete them in the Google Classroom. And at regular intervals, I have some short videos to discuss the knowledge in our topics. Right. So this is an introduction to FIFO. The concept is very, very simple. Very, very simple. Okay. So it is first in, first out. Those who go first definitely will receive the service first. So maybe for the handling of data structures, first element is processed first. Then of course the next element, maybe if you take in the case of ticket counter, the ticket checker will come, check for it. The first to get the ticket will leave, and of course second, third, and of course the last to get the ticket will leave the last. So this is how it goes. Okay. So this actually follows the first come first serve scheduling policy. So people enter the line, get the ticket and go. So the person entering the queue next will get the ticket next after the person. And of course, you know about it. I don't have to discuss more about the first in and first out approach as well. So where it is used? In data structures, for example, if you have to follow a queue, then you should follow this first in, first out. Okay. So there are other variants of queue as well, where you can use a different variant, but of course the basic principle or maybe the procedure that we try to follow are the same. Also for the disk scheduling procedures. For example, you take in the case of disk controllers, you can use FIFO as a disk scheduling algorithm. You can determine the order in which you are going to process the service disk input as well as output request. In communication and networking, you can use it as network bridges, switches, or maybe routers as well, where you can use FIFO, first in, first out, to hold the data packets and to pass through to reach the destination. So this is a C++ program to demonstrate working of FIFO using queue interface. So normally you will have bits/std c++.h using namespace std function. You are including the standard libraries and you are going to print the elements of the queue. So for this you are going to have void print queue. Queue you will have in queue, while this queue empty, the empty queue, okay, the not equal to. Okay, so see out you are going to print queue.friend. Okay, so this you are going to print out and you are going to pop, you are going to add to it. Okay, then you are going to go with see out in one, and then you will have the driver code in main function. Queue you will have in queue. Okay, and then you add the elements like 0, 1, 2, 3, 4. You are going to append to the queue. Okay, Then you will have the for loop. For int I equal to 0, I less than 5, I plus plus. Then you are going to push it. You are going to maybe remove it. Okay. Then you are going to display the elements of the queue. So see out the elements of the queue. Then after printing the elements of the queue, you are going to print it out. So there is this print underscore queue of queue. Okay. Maybe in the queue, whatever you are trying to happen, you are going to process. And maybe if you are going to remove the head of the queue, maybe you can have like a 1 0 1 2 3 4. Maybe the first element 0, you can actually remove it. Okay. So in remove delete equal to queue front and queue dot pop. That pop is actually going to do this function. Okay. So see out removed element. It is actually the remove element. So this is once again after doing this one removed element, then you are going to print the queue. Okay. Then after removing again, once again you are going to view this queue or maybe view this set of elements. Okay. So in head is equal to queue dot front. Okay. See out the head of the queue. So rest all methods of the collection interface, maybe like size, maybe it will be having this implemented model. Okay. So in size is equal to q dot size and see out the size of the queue is nothing but the size and return 0. So outputs you can see 0, 1, 2, 3, 4. You are going to add them. Okay. And maybe if you try to remove the head of the queue, maybe the first element if you are going to remove 0, then if you can see after 0 is being removed, you will have 1, 2, 3, 4 and head of the queue. Now the new head, earlier head is 0, now the new head is 1 and size of the queue 1, 2, 3, 4, it is actually 4. Earlier it was 5, now after removing 0 it is 4. Priority queue. Okay. So priority means you are adding or maybe you are appending any priority. Maybe some elements have higher priority, some elements have lower priority. Maybe even in the ticket counter also you give higher priority for those who entered first. Okay. Those who are doing more work, they are given more priority. But unfortunately, in organizations, in higher end organizations, the person who works more are given the least priority. And the person who doesn't work, who fabricate details, they are given higher priority. Okay, so this concept we are going to discuss in today's class. Okay, so the priority of the elements in the priority queue determines the order in which the elements are served. Okay, so elements will be having the same priority. Whatever the service we are offering, everybody has the equal right to demand for it. Okay, so not like you have joined earlier, so it should be given earlier priority. Everybody has got the talent, everybody has got the skills. Huh? So you cannot say this person deserves more respect than the others. Not like that. Right? All are equal. Okay. So priority queue is an extension of the queue. Okay. So every item will be having some priority, and we should actually give more procedural assignments as well. So element with the higher priority is actually dequeued before the element with the lower priority. Okay. And maybe if let us take in the case two elements are having the same priority, they are served according to the order in the queue. Now in this case, you follow the order. Otherwise, you don't follow the order. So this is the analysis of the priority queue. Maybe you can have this one, the operation, return value, and then queue content. So maybe you can say like in the letter, I mean in the word called coding, first of all. Okay. So you first of all insert C or you try to append C. So you'll have C and then you try to append O, which is O, and then you append D, which is D. Now after COD, you are going to remove the maximum. Now in this case, the maximum is actually O. So this is actually removed. So after removing this O, the maximum from this COD, it becomes C and D. Now you insert or maybe introduce I, which is I, insert N, which is N. Now you remove the maximum from C, D, I and N. What is the maximum? N is the maximum. So you remove the max. So it becomes C, D and I. Again you insert or add G. Okay, C, D, I and G. So this is how it goes. Okay. So the element which is having the value is considered for assigning the priority. So of course element with the highest value should be given the highest priority and element with the lowest value should be given the lowest priority. but, 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 the reverse can also be used. The element with the lowest value can be assigned highest priority, and the priority can be assigned according to the needs. Maybe he has some issues like Erali, who comes last, but definitely he also wants something, so he should be given more priority than the others. Okay, so operations, we will have like insertion, you will have deletion, you will have priority issues as well, so that we will see. So insertion, maybe you can add a new element in this priority queue. Maybe if you are going to add a new element, it requires a space, so which means that it moves to the empty slot from top to bottom and maybe left to right. Okay, so this is how it goes with the addition or maybe insertion in the priority queue. Whenever you are adding, there are no chairs, immediately you pass, okay, left to right or maybe top to bottom. So if the element is not in the correct place, then of course it will be compared with the parent node, okay, and if the element is not in the correct order, okay, then you have to swap it according to the order. Okay, so swapping process continues until all the elements are in order. And then deletion in the priority queue. So maybe if you take as you saw CODING, we saw the maximum heap. So maximum element you call to be the root node, and it will be removing the element which is having maximum priority. This is the reverse case. Okay, so it will be removing the element which is having the maximum priority. Then you remove the root node from the queue. Okay, so it is going to create an empty slot and it will be filled with the new insertion as well. So newly inserted elements with all the elements will be maintaining the heap invariant, and you can maintain the order also. Okay, so maybe if you take in this case 2, 6, 7, 10, 11, 2 low order, it is nothing but element which is given the highest priority. Okay, 11 is nothing but the highest element which is given the lowest priority. Okay, so it is going to return the maximum element from the maximum heap to the or the minimum element from the minimum heap without actually deleting the node from the priority queue. So this is how it goes with the order. Okay, right. So we'll have like different types of priority queue also. Like we'll have ascending order priority queue, descending order priority queue, and we'll understand the difference between priority as well as normal queue. Okay, so ascending order, as the name suggests, you will have to maintain a ascending order. So lower priority value, of course, it is given a higher priority. So that is what we see in the diagram. For example, we see like 4, 6, 8, 9, and 10. 4, the lowest number, it should be given highest priority, and 10, highest number, it should be given the lowest priority. Then of course descending order, as the name implies, descending order it is being performed, and root node, of course, it is the maximum element, and it will be removing the element with the highest priority. So if you can see, the root node is actually removed from the queue. So if you remove one particular element, then that will be creating an empty space, and there is a provision that you can actually add or maybe insert. For example, if you see in here like COD, if you can remove O from this, okay, still this empty space is there. This empty space is there, which means there is a provision for inserting or maybe adding a particular element or maybe value. Okay. So the heap invariant is maintained by comparing the newly inserted element to all the other entries in the queue. Okay, and of course there is difference between a P queue and then N queue, priority queue and then normal queue. Okay. So here, with the case of priority queue and the normal queue, there is no priority with this queue as well. So since there is no priority, you should follow the first in first out. Either it should be first in first out or it should be priority. Okay. So there is no priority associated with it with the case of normal queue, but in priority queue, elements with higher priority are served first. How you can implement it? You can implement using arrays, you can implement using linked list, heap data structure, and BST, binary search tree. Heap data structure is also the same. We'll have maximum heap, minimum heap. We'll perform this push operation, pop operation. Arrays, linked list is a combination of different arrays, and you can actually do much more. BST, of course, like data structures, we define linear search, binary search, The same. More similar only. The subjects what and all you study like data structures, technological innovation, new media, algorithms also. Even an algorithms also, I will discuss about merge sort and then bubble sort. Bubble sort, merge sort, algorithms we will be discussing. So almost you have studied the basic important concepts. So brushing them and then you should know the idea. That is the. So this is using array. You can implement the PQ using array. So maybe you'll have struct item, initialize the item, and then initialize the priority. And maybe you can have NQ operation, DQ operation, peak operation, and then top operation also. Okay. So NQ, you are going to add the new data into the queue, and DQ, you are going to remove the element from the queue. Okay. So whatever it is having highest priority, you remember the last thing we saw. Removal means those are having highest priority, it's actually removed from the queue. Okay. And then peak or maybe top. Okay. So it is going to get the highest priority element in the queue without removing it from the queue. Okay. So you will have NQ, DQ as well as peak. Okay. So you'll have the time complexity. For NQ it is order of 1, and for DQ and peak operation it is order of n. So this is a C++ program to implement the PQ using arrays. So hash include bits slash stdc++.h using namespace std function. So you'll have the priority queue structure. So the what we saw here, struct item, in item, you'll have in value and then in priority. Then you are trying to store this element into the priority queue. Okay, so item PR of 100,000. Okay. You're going to point to the last index in size is equal to -1, and you will have a function to insert this new element into the priority queue. So you'll have void NQ. NQ is nothing but adding. Okay, so in value, in priority, then you increase the size. For this you go size plus plus, and you insert the element priority size dot value equal to value, and priority size dot priority equal to priority. Okay, then you check the top element whether it is having this one. So in highest priority equal to int of min. So the minimum is taken as the highest priority, and int is equal to -1. Check for the element for the highest priority. So for you'll have the for loop for int I equal to 0, I less than or equal to size I plus plus. Okay. So priority same means then you choose the element with the highest value. So if highest priority is equal to priority I, that priority, and in indices is greater than -1. So ampersand priority indices dot value is less than priority I dot value. So highest priority you are giving it as priority I dot priority, and indices equal to I. Okay. Else if highest priority is less than PR dot priority, highest priority is equal to PR I dot priority. So int equal to I. So after doing this one, you return the position of the element, return the indices. Okay, and you have the function to remove this element with the highest priority. So after doing this NQ operation, then you go for the DQ operation. So void DQ, find the position of the element with the highest priority. So int equal to peak, and shift the element because we are going to shift it, okay, to one index. Okay, one index before from the position of the element. Okay, so for int I equal to int and I less than size I plus plus, PR of I equal to PR of I plus 1. So you are actually going to increment this one, and you are going to decrease the size of the priority queue for this DQ operation. Okay, so there you had size plus plus, here you have size minus minus. Okay, then after doing all this one, you will have the driver code. So this is the main part. In main function, you will have a function called NQ. You have 10 2 14 4 16 4 12 3, and you are going to store the element. Okay, so int equal to peak, and C out you are going to print this indices dot value, DQ the top element. Okay, for DQ, check the top element, you will have this peak function, and DQ the top element, DQ once again check the top element peak. Okay, and you print the value. Okay, so maybe if you can, you are going to see this one 10 14 16 12. Okay, so it will be assigned in the decreasing order 16 14 12. So this is WFQ. As the name implies, we are going to associate a weight to the FQ model. Okay, so it is going to create a queue based on the traffic flows, or maybe it is going to assign the bandwidth according to the flows. Everything is based on the priority. So sub queues are assigned bandwidths dynamically Suppose let us take in the case we have three queues, 20, 30 and 50. For example, everything is active. Maybe let us take in the case if 20 is actually idle. So the freeing up of bandwidth will be allocated for the remaining queues as well. And 30 is allotted maybe for the different types like 75 divided by 2, or maybe 50 maybe you are going to allot for the remaining 125 divided by 2 bandwidth. Okay. So maybe this one 50 percentage, 30 percentage, and then 20 percentage you will have packet 1, and remaining you can allocate for packet 1, 2, 3, and 4. 20 percentage you can allocate for only one. Okay. So traffic flows are actually you can classify and you can distinguish based on the source IP address and destination IP address. You will have source TCP, destination TCP. You will have IP, Internet Protocol, and you will have a service value also. Okay, DSCP. So you'll have the packets which is separated based on the distinct queues it is being followed, and maybe you will have maybe a maximum of 256 queues which can be established within the router. So even it can be increased up to 4096 also. Okay. So unlike the priority queue, the weighted fair queue are allotted different bandwidths based on the priorities of the queue. Okay. Packet with higher priority are scheduled before the lower priority queues arriving at the same time. So this is the independent work, video conferencing, military surveillance, interactive TV, and of course VOD, requirements and design challenges of the multimedia communications. I request you to please submit them in the Google Classroom as early as possible. As usual, be independent work and with the open-ended project work.